So the problem of missing values is that in some data analysis settings, we have only partially observed exemplars. So a very typical situation is if you do social sciences and you use questionnaires to acquire data. So you you have people fill in the questions, and well, some people will not fill in fully the questionnaire. Okay, that's not a question for me. So that's the first example. Another example is if you're doing data integration, you're integrating data from different databases or different tables. You might have missing correspondences across tables. You might have somebody who is in one table but not in another. You might have an entity such as a company, for instance, in one table but not another. And if you do the join to create the table that you need for the analysis, then you'll have some missing values there. And finally, you might have measurements that are not performed. For instance, due to the urgency of a given patient, you might not measure a patient's weight if that patient is bleeding a lot. So the problem of missing values is really ubiquitous in health and social sciences. Conversely, it's not very present in other kinds of data. For instance, when I was doing medical imaging, it was much less of a problem. Now, one thing that I'd like to stress about the examples that I gave before is that the missingness is noise, but it's also signal. If somebody is given a questionnaire and chooses not to answer some questions, there might be some information in there. Maybe that person doesn't know or doesn't want to answer. If some measurements are not performed because the patients were too badly ill, just the fact that those measurements are not performed tells us that the patient was badly ill. Inversely, the fact that some measurements were performed tells us some suspicion about what the doctors thought. So this is a bit the setting, and the questions that I'm interested in are, given those settings, how do we build good predictive models on such data?